Okay, let's start this training session. Welcome to this session on ProSBC 1+1 solution with transcoding. So just an overview of the ProSBC functionalities. It is a SIP device. You can receive SIP calls and make SIP calls. Here I show two service providers, but you could have a large number of service providers, also registered users, access to different phones. So it's a very flexible device. It offers protection against denial of service attacks or distributed denial of service attacks. It does network adaptation between different SIP networks. You can do SIP-I, SIP-T, SIP-TLS for encrypted sessions. We do SIP header manipulation, advanced call routing. We can store call detail records. We also with radius interfaces. We can do cause code mapping. We have all kinds of troubleshooting tools to help us work on these systems. Plus, we have RESTful APIs to configure and SNMP interface for monitoring. We can also monitor with the RESTful API. We have other sessions that talk about these functionalities on the ProSBC. Here, what I'm focusing more on is the high availability solution. So when you want to design a high availability solution, you have multiple things you need to think of. First is to have multiple instances of our SBC device. So in our case, it would be ProSBC Plus. You need also to have network diversity so that you have multiple network paths in your system so that if one network path comes down, everything continues to work. This is mostly managed by your Ethernet infrastructure. Then you have applications that are running inside those SBCs. If they fail, they will restart automatically. And if there's a complete failure of one device, the other one will take over. One of the things you want is to have identification of issues in your system. So you need to monitor all of these systems. You need to do health check on the networks surrounding the SBCs plus the SBC itself to help you identify the source of the problem. Then you need to prepare an action plan in case of failures in the networks. What do you need to do? How to replace ProSBC? How to replace a switch? If it's running on bare metal, then you may need to have a spare unit somewhere there. If it's a virtual machine, you know how to restart a new virtual machine and instantiate another instance. Okay. When we run on HA solution, what we have is high availability communication between the two devices, the primary and the secondary. Both of them are configured the same way, and they have the same, let's say, the same licenses, except the secondary has a special secondary license. The rest is identical on both systems. The replication is done from the primary to the secondary, but if ever there's a switchover at some point, the configuration replication will switch from the secondary to the primary. There is heartbeat that is done between the SBCs. There's some checkpointing that is done as well. The master of the system is automatically selected, and it will, if ever there's a failure, it will automatically recover itself. You can add hardware transcoding to a ProSBC high availability solution. What does the transcoding device add here is the vocoders. Right? So in a regular ProSBC system, the ProSBC will verify the transcoding used for the media on both ends and try to use one that is compatible so that you don't need to do transcoding. If you need to do transcoding or if you want to do transcoding, then the ProSBC will decide when this needs to be used. And you can transcode from any of these vocoders that we see here. So it could be G711, which is the most used, and then you can convert to G729, G722, narrowband, wideband, AMR, and then we also support the T38 functionalities. right? Plus the clear mode, which is usually for modems or secure channels, which then you disables all the special functions of a RTP network. We can also do DTMF and RTP events. So it's RFC 2833. There's another RFC that talks about that and convert that to in-band DTMF tones. So there's some networks that support only in-band tones. So that's possible to do with the transcoding device. In addition to this, you can play announcements and you can record the media streams with those transcoding devices. When you have your ProSBC 1+1 configuration like this here, you have your HA communication pad that is enabled, and it will use the same paths to connect to the transcoding devices. So there will be communication between the SBCs and also from the SBCs to the transcoding device to, allow the configuration of that device. There is also a separate path for RTP. Okay, so if there needs to be transcoding, it will use this RTP path to transcode the media stream. These networks here are usually private networks. Okay, so they can be on separate VLANs, separate Ethernet switches, and it's like an internal network for the global system. Okay? You can have up to 16 transcoders enabled for a ProSBC system. Okay, so how it works normally is that if you don't have any transcoder device, or if you don't need to do transcoding, the RTP will be, well, there will be SIP communication here between the endpoints. If you can match the vocoder used, then there will be RTP passing through the ProSBC without transcoding. If you need to do transcoding, so that means on the SIP communication, you can't find a vocoder that is compatible, it will then allocate some resources on the transcoding device so that your RTP will go through the transcoding device to the other end, and these can be different vocoding sessions. The control of the transcoding is done through this HA communication channel. Also, if we look at the network connections of a ProSBC, in this case, a standalone, so you can have a ProSBC running by itself, you always have a management interface here to be able to configure the system. And we also use that usually for monitoring status and stuff like that. But you could use other interfaces for management as well. Okay? So you can add other interfaces to the system for management. You normally have at least two network interfaces here that are what we call SBC protected. Okay, so that means it goes through our SBC firewall, and if you have any types of attacks or stuff like that, it will be protected in this case. Normally, one is for the local area network, one is for the wide area network, but you can have many more interfaces on those systems for all kinds of purposes. These networks here, well, for a bare metal system, these will be physical interfaces. So different physical interfaces on the system. It could be on the same physical interface, but different VLANs. So that's also possible. Or you can have virtual interfaces when you're running on virtual machines. These are all virtual interfaces that are connected to different networks in your virtual environment. When you go to a ProSBC 1+1 solution, what you have is your ProSBC primary, which has the same interfaces that we saw before, but you need to have two additional interfaces for your HA communication. They are called CTRL0, control 0 and control 1 for communicating. When you configure the secondary device, you need to make sure that these naming conventions are the same on the primary and the secondary. Okay? They need to be the same names. Control 0, control 1 are configured automatically, so you don't need to rename those interfaces. but the LAN one needs to be the same on the primary and the secondary server, because you can put whatever name you want here. Doesn't apply to the management port in this case. Okay, so what you have is one management to reach the primary system, one management to reach the secondary system. You have your main SBC interfaces here, which face the local and wide area network, plus your HA communication, which has the HA communication for our heartbeat, the checkpointing. And the IPs here are static, so meaning they won't change over time. Same thing for the control ports here, so they will be static IPs. But the two other LAN 1 ports will be floating IPs, meaning that if there is something that happens with the primary, these IPs will be reused on this secondary. There will be reverse hard sent on the network so that the network knows that the IPs are now handled by these different MAC addresses. When you add the transcoding device, you see that you will have a management interface for the primary and the secondary SBC, but it is not needed for the transcoding device. The transcoding device will communicate with the primary and secondary ProSBC through these control interfaces. So all the communication will go out these ports and be sent either to the primary or the secondary system. If these devices need to use the transcoding, it will send some requests so that it is configured properly. In addition to the control ports, when you use a transcoding device, you need to have two additional ports, which are transcoding, where the RTP will be sent. So again, these are normally private networks, and they only need to communicate between the primary and the transcoding devices here. Okay, so here I show some lines going out, but they don't need to be going out to any other network. They can be just local interfaces here. They could be also, and you will see in my demonstration system, they're on specific VLAN, so they're isolated from the rest of the configuration. So I will show you how to configure this. Yeah, so one more thing is these trans 0, trans 1 are actually the same type of interfaces that we configure for the general network, but they are here used only locally, and that's why I put a different color here. But when you do the initial configuration, you will see that these are LAN 1 ports. So once you bring up your ProSBC the first time you access the system, it will bring you to this configuration page. This configuration page is very important. It matches your physical ports to your internal network. Okay? So that's where you will assign the MAC address of the physical ports to how the ProSBC will use those MAC addresses. Okay? So you need to have at least one management port. Here, normally, when you get to this page, you have already accessed the web interface. So it shows you here in orange that this is interface you're using. So if ever you change this port, you need to be aware that you will lose access to the system, which may be normal in some cases, but normally when you configure the management 0 port, you will stick with this management port. So normally you don't change this first line here. One additional thing you have here, you have the MAC address, of course, which is what we use usually to identify which interface we're using. But if you press plus, you get additional information, which can help you to identify which port you want to use for which type of service here. When you use 1+1 and when you use transcoding, you need to have two control ports. Here you see that the names are predetermined and cannot be modified. So if you choose control 0, the name will stay control 0. If you choose control 1, the name will stay control 1. So it's attached like this and you can't modify it. But you can still choose which interface you will use for your high availability communication in the system. You need to have at least 2 LAN1 ports if you are using transcoding. So you need to have 2 interfaces. In my case, it is this one down here and this one here. So I've used specific interfaces that I configured on my VMware architecture. And these will be restricted for transcoding use. I then have more LAN1 ports for SBC. So this one, this one, this one, this one, this one, all ports that I'm using in my ProSBC tool for different purposes. My 600 network and my 800 network are private, different VLANs, different private networks that I'm using. So you just need to choose all these roles in your system. Once you have chosen this, you will, start using the system. If ever you have made a mistake in those ports, it's possible to change it. Once you've gotten into a regular system, you can go in the host section, click on status tab and select change network device roles here. It will bring you back to that page that we just saw, and then you can choose or modify the configuration. The other thing you can do is reset host role. You see here, reset host role. This, if you made a mistake in which, if you're changing from standalone to primary or you primary to secondary or something like that, you can do this as well. It's gonna let you choose that. When you add a new interface to a VM infrastructure or a physical bare metal server, you add a new network interface card, it will get you to that previous page, and you will need to assign what you need to do with those interfaces. There is another option which I did not show here, and it is called unused. So if you're not using that interface, you can just select unused, and it won't be configured by the system. So when you add a new interface, you do a reboot of the system, it will get you to that page, and you need to select these new interface, what you do with, what you will do with those new interfaces. The transcoding device itself. Okay, so the part we just saw now is the ProSBC configuration. Then you need to add your transcoder to your system. You will have 4 ports actually on these devices. 2 of them will be high availability ports, okay, ETH0, ETH1. And it's just named differently, but it's the same as ETH0 is the same as control 0, ETH1 is the same as control 1. So to have access from your ProSBC here, your control 0 port will need to be on the same network as your ETH0 port. Same thing for control 1, ETH1. You have 2 other ports on these devices, which are called VoIP0, VoIP1, and it's actually the same as Trans0, Trans1. So from the ProSBC, your Trans0 network will need to be on the same VLAN and same subnet as your VoIP0. Same thing for VoIP1. This is where your RTP will be flowing from the ProSBC to the transcoding device. There is a management 0 interface on those devices, but you don't need to use them, as all the communication will go through these control ports. When you install this transcoding device, just before you access it, you need to change those Ethernet ports so that it matches the controllers. Okay? So the the interfaces that you will use there need to be on the same network as your control ports there. So you need to verify what are the control ports and configure that on the transcoding device. Right? To be able to change those Ethernet ports, you need to use the serial port. So in the installation guide, it explains how to do this. Here you can connect with the USB. So just connect a USB port here to be able to access it. Or you use the regular, more DB9 type interface here. This is a RJ45 going to a DB9. You need a special cable for that. And you can, in both cases, configure the device. There is no password to access when you connect to the serial port like this here, and you will get to a prompt that looks like this, 0/tbgw. You can, there's many options you can do here, but the only function you will really need is set_net. Is set to set these ETH0 and ETH1. So normally it's not using the HTTP, and you need to put an IP that will be reachable from the from your ProSBC control ports, the high availability ports. By default, I think it's using a very large subnet. So normally we want to use a smaller subnet here. And it's all untagged. Okay, all the interfaces here are untagged. If you want to tag those interfaces, you need to configure the Ethernet switch that you connect to and force it to go on a specific VLAN. Right? So all the interfaces on this device are untagged. So once you have done your setnet and you set all your IPs that will be used for the control port, you just need to type reboot, and it will be now have these Ethernet ports available. You can verify this with the printnet configuration. So of course, you need to connect your cables so that it can reach your ProSBC. What you need to do in your ProSBC then is to go in configuration, select your current configuration, go in the web profiles, and enable the transcoding units to be detected by the system. We can just select here hardware unit. After you have done this, the hardware unit segment here will appear. So it was not there before. Once you select hardware units, this will appear in your menu on the left side. Once you click hardware unit, you can say create new unit. And here you need to give it a name. And you need to input the serial number of the device. If the device is already detectable, it will display the list of transcoding devices that can be configured in the system. If it's not already configured, then you can just put the serial number of the device here. And once it is seen on the network, it will be automatically detected and added to the system. Type here is TDM or IP. You can put a location, what type of device this is. And you can put here TDM line type set to none, but actually it doesn't matter what parameter you put here. So the main parameter is definitely the serial number. It has to match the serial number of the device that you add in the system. Once the unit has been detected, you will then be able to see the IP interfaces of that unit. So these will, if you click on the IP interfaces, you need to select physical ports here. You will see these ports. You have nothing to do there. These ports are automatically added to the system. They will be on the same network as your control network of the ProSBC. And it will be, the void ports will be your transcoding ports. Just to be clear here, there's two segments which are IP interfaces here. One is really for the transcoding devices here. One is for the ProSBC functionality. So slightly different here. One thing you will need to do here is configure your transcoding ports, the VoIP ports here. You need to put the IP addresses that you will use for your transcoding network. So in this case, I've used these IP, which are a private IP. So I just use a different subnet that has not been used in the rest of my network. And here I put the VLAN that it's being used on as well. Right? So I've used the VLAN as my subnet just to make it easy. Here you see there's a gateway, but since it's a private network, we don't need to configure that, or you can just put the same IP as the VoIP ports. Right? The services are always there. I don't think we can change that. But anyway, it has to be at least RTP configured here. So now we've configured the IP interface of the transcoding unit. We need to do the same thing in the ProSBC segment. If you click on IP interfaces here and virtual ports, you will need to make sure that you have access to that transcoding network. In my case, I'm using VLAN 776 and VLAN 777. So I know that these are my two interface that I'm using. So you can just, if you don't have it yet, create new virtual port and add those VLANs to be available from the system. Okay, so the trans 0 that I will configure at this level will be the same as the VoIP 0 and trans 1 same as VoIP 1. All right, then I configure in IP interface section. This is where I give the name trans 0, trans 1 using my VLAN I just configured here. And you see they need to be on the same subnet as the transcoding device. Okay, again, here I need to have at least RTP configured in the system. Okay, so once you have that, there's communication between the controller, the ProSBC controller, and the transcoding device. When you configure your network access point, which are also IP destinations here, you have a segment in the profiles configuration, which is important for transcoding. Right? So I just extracted from the profile this, which is pretty extensive. And then you can do some tuning here. First is allow audio transcoding, which is on by default. So you just make sure that this is enabled by default, and also allow low media relay. So this means you can use direct connection on RTP. If you remove this, it will always use a transcoding device for your communication. So normally these two checkbox should always be marked, and by default they are always marked. Here there's an option for codec selection. So either you use all compatible codecs. So in call, you can switch between codecs, or here you can use only the active codec. So then, for example, if you choose G711 MULA, it's going to stick to G711 MULA for the duration of the call. Here, by default, the ProSBC will automatically choose if you want to go to from in-band to RFC 2833, but here it's possible to force it. So if you select this, you would always force the transcoding to go from in-band to RFC 2833. Remember, this is configured per IP destination, right? So one IP destination could be forced to in-band, and it may not be true for another destination. There's other stuff down here. This is for SRTP use. This is for no anchoring, meaning that the RTP is not controlled by the system. So of course, this needs to be unchecked for the transcoding device, because only if the ProSBC manages the RTP, can it go through the transcoding device. And then you have here, allow other codecs. So the ProSBC will just, if it doesn't recognize a codec and the other side supports it, it will automatically manage that specific vocoder. Right? So you can configure this per network and add it to the network configuration. But that's all you need to do for in the configuration. There's nothing else to do. The rest, the ProSBC will choose when these interfaces are being used, when the call needs to be transcoded or not. So everything is handled automatically by the system. If you want to see the status of the transcoding unit, you can select which transcoding unit you want to see and go here in hardware unit status. Here you will see which units are currently in the system. You will see if they are ready or if they are either not configured, or in this case, it is not even detected in the system. So you will see something like this, but you could also see other elements here. For example, is it upgrading? Here you can see the CPU usage of the devices, but it will always be very low for a transcoding type of device. So if you go back to the ProSBC itself as a 1+1 configuration, you can go in the main status tab here, look at the host section, and you will have your two ProSBC, the primary and the secondary. You will see if they are ready or not. If they're not ready, you can select that device. Let's say, for example, A3 is not available. You can click on it, go in there, see what is going on for that particular SBC. Same thing for the hardware units. You can click on hardware units, see both of the devices, what is going on with the device. Why is it not detected? I will show you this in my demonstration in a minute. And here, I did demonstrate it here, hardware unit. So you can see one of them is active and ready to be used. The other one is not active. So it could be the Ethernet control ports that are not configured correctly. It could be that there's something else cannot communicate with the device. One more thing I want to show here is that when you click on your transcoding device, you have multiple things here. You can choose. You have sensors here for temperature, voltage on the systems. You can see what are the licensed features. In the case of a transcoding device, it will only be voice over IP resources for transcoding. But the one interesting thing here is the usage of the voice over IP resources for the transcoding. In this case, if you see 3, you know that there's 3% of the resources that are used. If you use basic transcoding like G711, it's very low, not intensive on the VoIP resources. If you use G729, AMR wideband, these are more complex vocoders, and they will use more of those VoIP resources in the system. So you can see if you are getting to the limit of your transcoding devices by looking at this parameter. If you have multiple transcoding devices, the load will be shared between all those devices in a system. Now, to troubleshoot the ProSBC with transcoding, one of the things you will look at is the call trace from the web interface. These call traces can be downloaded in HTML format. One of the things you will see here is that on the 200 OK received from the remote side, you will see which vocoder is being used first, right? The first one in the list here is the one that has been chosen for that communication. It's not necessarily described here in the list since these are static payload types, so they are well-known type of vocoders. For example, 103 G722 is not defined here as a well-known, and you can use this this RTP payload type for your communication. Okay, so these values you see here, you will see in the RTP communication. All right, so and Wireshark can decode this. It knows that if it's G729, it's going to be 18. Right, so it can make the match between that. And here we see that the 200 OK sent to the incoming leg is now using 0. All right, so using 18 on one side, 0 on the other, you know there will be transcoding. If you get to the end of the call here, at the end of the call, you will get a MOS score, a mean opinion score on the communication. And you will see, for example, what type of vocoder has been used on this side, what type of vocoder has been used on that side. So from incoming to, from the incoming to the ProSBC and from the outgoing to the ProSBC. So you can see it here. If you want to see the signaling trace, you can still do TB6 trace. To do this, you need to connect to the SSH port, and you will see those same messages in the SIP configuration. You will not see the MOS score in the SIP call. Okay, the MOS score is only internal to the ProSBC. These MOS score actually are being put into the call detail record. So you can see for each call that went through the ProSBC that what is the MOS score for these communications. Okay? If you lose packets, if you have sequence errors, the MOS score will go down. And I will show you what to do this. I just want to here go through the different troubleshooting tools. You can also do a full packet capture, okay, on the ProSBC. full packet capture will give you not only the SIP, but also the RTP stream. It will give you the ARP request, okay, address resolution protocol request to identify the MAC addresses to be used for each of the IPs in the network. Okay? To activate this full packet capture, you need to first access with SSH, type this TBX CLI tools remote command. You need to select the active TB router in the system, and then you need to type P, okay, to start the packet capture, and then P to stop the packet capture. Once you have captured your packets, you can then use SFTP to get that file. Now we are at the demonstration of the system. So my demo system is running on VMware. So I have two ProSBC running as primary and secondary, called ProSBC VM A2 and ProSBC VM A3. Both of them work in pair. I have another ProSBC here to generate a call, and here I forced it to be G711 only. So the call that comes in is only G711. And then I'm using SIP-P here to receive the call, and here I forced it to be G729. So then if the communication goes in here, here is forced to G729. So now we know that we have no choice to do transcoding. So if when the call comes in here and it negotiates G7 event, 729, it will go here through the transcoding device and force a transcode. Okay, so here are the links, but before I go there, well, I won't come back to the presentation, so you can see those links. I will show you that in a minute. The system looks like this. This one. All right, so my system looks like this. So first, normally you start with the global status. Global status tells you the date, the time, if you're on connecting to the primary host or the secondary host. You can see also the version, how long it has been up, and the databases, which holds the configuration. You can see the current number of calls. So there's no calls running on my system currently. You can see the ProSBC itself. Okay, if they are ready. If they're not ready, there could be all kinds of other situations, and each of them have different procedures to verify and fix. You can also see all the ports if they are connected and up in the system. Yeah, so you see all of this here. Then you have your hardware units. Hardware units are actually the transcoding devices. Here you can see which one are active, which one are not. If you select that particular device, you can see more information, which version it's running, is it ready, hours in service, and then all of these information here. You could reboot the transcoding device, but it's don't need to do that. This is the usage that I mentioned. So if it's being used, you will see the percentage of usage here. I mentioned other sensors and how many calls it can do. Here I use a transcoding device, which is really small. So I have only 60 resources available to do my transcoding. Going back to the status here, here you see there's other stuff, but not so important in our cases here. If I go to the hardware unit here, this is where I do the configuration. So I would need to do here, create new unit to add this device. You need to make sure the serial number is the correct one. So this is the very important parameter. That's what makes the link between that transcoding device and the ProSBC. And you can give it a name. Here I give it a generic name here. The rest of the parameters are not so important here. If you go to the IP interfaces section, if I go on physical ports, you see I have my physical ports for my my 2 units, but only one of them is being used actually. ETH0, the control 0 parts, ETH1, control 1 parts, VoIP 0 are my transcoding 0 parts, transcoding 1 parts. Virtual parts you see here, they're all untagged. Okay, so I can't configure a VLAN on those parts. They're all untagged. If you want to put it on a VLAN, you need to have the switch, Ethernet switch port that you connect those ports on to force a VLAN on them. The IP interfaces here is where you have to configure the VoIP interfaces, but not the ETH ports. Okay, the ETH ports here, you cannot modify this configuration. Okay, so you see, you can modify it here. It's read-only. The way to do that, I'll show you in a minute how to configure those IPs here. You see, my default netmask is pretty big. Normally, we don't want to use that in a live deployment. So we will use a smaller net mask and maybe a specific VLAN for this. Yep, that's it here. There's no other stuff that is interesting in this configuration. The other configuration that is important is your IP interfaces here. You need to make sure that you have your transcoding ports available here, trans 0, trans 1, on the same network as your IP interfaces of the VoIP ports. Okay, so they need to match. In this case, you see I'm using VLAN 776, VLAN 777. So the ports of my transcoding unit are forced to be on those two VLANs. So the configuration of the transcoding unit is untagged, but I force them to be on VLAN 776 and 777. There's our private network, so it's just inside our system here. Okay. So you can then select status here. In the status, you will see the MAC address of all the ports being used in the system, including the transcoding ports. Transcoding is active standby. So you see here, there's only transcoding 1 that is actually transferring packets. If transcoding 1 goes down, then it's going to be using transcoding 0 interfaces. You can see the same status here. If you could go on IP interfaces and look at the status here, you will see the MAC addresses of the different ports and which current IP address is used. And if it is available, link speed is all 1 gigabit per second for all these interfaces. It's enough for running thousands of transcoding services here in the system. If I just look at the virtual ports on the devices, they're all untagged. So for sure, the VLAN tagging has to be done on the Ethernet switch. These are internal VLANs that don't need to be managed by you. So I just go back here, IP interfaces, virtual port status. Oops, virtual port status. I just wanted to show here. Yeah, we have to go here on VLAN to see the VLANs that are being used on the system. Okay, so here, that's why I give the name here to make sure that it's clear when you configure the system which VLAN is being used. Okay. So that's about all for the configuration and the status. Then I would go here in the Gall trace to see calls that are running in the system. So let me just place a call in the system. Okay, so I see here my call that is ongoing. You can see the call ID that is being used for that particular call. You see the call is ongoing right now, and it has it's yeah, going, and you see what it's doing here. I will stop the call just to make it complete. Okay, so you see the call here has been 36 seconds. You see the which network access point, which IP has been used for the call, and what is the outgoing. You see the incoming invite of the system. You see the what we are interested here is the SDP that is being used, so which vocoders are being used. So see the offer here is 0. Okay, 101 is for DTMF events. 13 is for silent suppression. Okay, so but the main vocoder here is 0. And what is sent outside is the 18 here. Okay, so it's 18. And maybe I can just show you how I force this to 18. I go in my profiles and I created a new profile that's called G729. Okay, so I just copied from the default configuration. I called it G729. And in my SDP, I forced codec 18 here, which is the G729. We have documentation on how to configure this SDP profile. And you can see my media relay configuration here, which is, in my case, the default one. If it has been changed, the color of this parameter will also change. It will be set to orange. So maybe I can just show that. Okay, go back to G729 here, go back to my media relay. So you know that this has been modified from the default configuration. So this is how I forced my G729 on my outgoing leg. So going back to my call here, I have my invite going out 18. But the most important is the 200 OKs. That is where the response will take place and which one has been chosen. So the first one is 18 in this case. And in my 200 OK here, the default is 0. So now I know that there will be transcoding in this communication. All right. Then we have the buy, which is 35 seconds later. If you get here, we have the final statistics. You can see how many packets were being sent, plus the quality of the call. And you can see one way here is 4.3 PCMU. So that's coming from the other side to us. So we can evaluate the quality coming to us. Here, this leg, it says 0 because we can't evaluate the mass score of the other leg because in this case, our TCP is not enabled. So we don't see this. Okay? Same thing on this side. What we receive is G729AB, which is a maximum mass score of 3.7. We didn't lose any packets. So you see here error 0, no packets lost, but still, because it's G729, quality is slightly less than the G711 All right, so you have this. One thing you can do here is export, right? So you can export this call trace, very useful for checking this trace without having access to the system. Also, if you require the help from TelcoBridges, you can also use this. Okay. Apart from this, the rest of the tools will be in the SSH interface. Okay? So you can do a TB-sig trace like this. You just type TB-sig trace. It will automatically start a signaling trace. And if you have a call, it will register some events here. The file will be called, in this case, tvsip0. You can open this capture file. So we have many presentations that show how to do this. So I don't want to go further on this part. However, what I want to show you now is how to do the RTP trace. The RTP trace is not only RTP, it will have the SIP information, the RTP information, and all the ARP information. Okay, so you still need to connect SSH to the ProSBC. It could be the primary or the secondary. It doesn't matter in this case. To be able to enable the trace, you can type TBX and you press tab. This will come autocomplete to TBX CLI Tools Remote. Press enter, get access to the this menu here. You see all the applications are running for the ProSBC, which includes, for example, SNMP. It has the web interface. It shows everything here. But the main one you want to have is the one called TB router, and the one that is green. So you see here, TB router is green, TB router is yellow. So we know now that it's this TB router that is running the system. It's running on the secondary. You see the primary is the green one, secondary is the yellow one, but it doesn't matter. The system can run primary or secondary independently. So You can just go with the cursor, go down here, or you can just type S here and go directly to TB router here. Right? So there's a lot of information that is displayed here. You can see all the packets that are coming in, the IP address that are being used, the CPU for getting all these packets. So you have a lot of information here. However, what we want to do is the option P. Okay, so you can do question mark here, help to see all the possible options, but the main one we want to use here is P start stop capture. Okay, so in my command line, I just type P. It shows a menu like this. You only need to press, there's some filters, but you only need to press enter here to start the capture. It starts capturing packets. I will do my call, so we have something that goes on. Okay, I will let it run for a few seconds and I will stop my call. And here I will stop my trace. So you do P again to stop the trace. The capture is always in this folder, okay, called user lib tb toolpack tb router in the pcap section. And here you have the full path. So it's very easy to just take the full path here, connect with SFTP to the device, and put the full path here. You get direct access to that trace that we just captured. Right? So I will just put it here. Okay, so I have my new trace here. And we can now open this trace with Wireshark. Oops, here. Okay, and just put it slightly bigger here. So, like I said, you see all the ARPs, which could be interesting for some troubleshooting cases. You have also UDP packets, and now you see you have SIP and RTP. Right? So what I will do first is do the SIP, and then you see the invite that I've just done. You can, oops, you can see what has been set, plus the SDP, which is what interests us here. So the 0 here, and the invite going out 18, the 200 OK receive 18, and the 200 OK for the initial leg 0. So now we know that there is some transcoding going on. If we do SIP or RTP, oops, or RTP, okay, we have then the RTP that is being seen as well. Okay, so let me just open the path here. So I forgot to, you saw the IPs in the system, but I forgot to clarify that. So there is G711 here coming in the system and going back to the incoming leg. There is G729 going in from the outgoing leg and out to the outgoing leg. So you see the values that we're using here for the this, and if you open the RTP, you can see the G729 here that is being used. You can also see the ports that are being used for the RTP stream, which can be useful if you have a lot of RTP streams. You can filter on those ports. Here you see them in the invites here, right? 20012 to 6000, right? So you can filter on that as well. Now, what is confusing slightly here is that you see the incoming and the outgoing leg, but you don't see how it's being transcoded. So to do this, you can add the UDP. Okay, the UDP, and you see here, there's G711, G711. These two legs here are the internal legs, but Wireshark cannot decode those streams by itself. Okay, so the way to do this is right-click on that stream, decode as, and here you need just to put RTP, decode as, okay, and then, oh, suddenly it can detect that this is the incoming from the incoming leg. This is going to the transcoding device, okay, and it's coming out as G729 on the other leg, right? So G7, G7, G729, G729, and then the other side is the same. So G729 on one leg, G711 on the first. Right? So you can follow the path of your streams, but you see you will have 4 G711 streams, 4 G729 streams in your system. Okay? It does use up more resources of the ProSBC to do this. It doesn't count as an additional session for the transcoding path. Okay? So this can help you to troubleshoot and see the RTP stream that you have in the system. Okay? Just go back here, RTP trace. Okay. Okay, now last thing I want to show is the transcoding device itself. So you can telnet to the transcoding device. If you don't know the IP address of the transcoding, you can go in the section that's called Poolpack Engine here. Okay. And then you can see the IP of the transcoding device. Okay, so you can do here print net to see the IPs that are being set on the device. You can do set net to change those IPs to the correct ones. You only need to change the ETH0 and ETH1 IPs. You don't need to change the VoIP IPs in this case. Okay? The initial connection you have in the system is usually a serial port, and you get exactly the same interface. You just need to do set net, put your IPs, and then you do reboot to force the new IPs to be set on the system. Last thing I want to mention is the different documentation we have on this. So it's always docs.telcobridges.com here, and we have different different pages. ProSBC transcoding solution, which explain how it's done, how many transcoding we can do depending on the different vocoders. So you see here the AMR wideband is more heavy than, let's say, G711 in-band to RFC 2833. There's other links here, which I showed this page here. So it can show you how to configure your network setup, a bit like I showed in the presentation, how to do your initial configuration. This is a use case, so a specific use case for what one type of configuration that you have on a system. And here I show how to capture the packets on the ProSBC. Okay, so I've shown this in the presentation as well. So this concludes our ProSBC 1+1 with transcoding presentation. Hope you enjoyed it. Thank you very much.